I'm very excited to be with you today because I am participating in a machine that I didn't previously know quite as well as I do now, and I want you guys to know it like I do. This is Nomura, and we're very excited to talk about this today with Andrew, and let me tell you why. There are some companies out there that maybe don't have the strength in marketing currently, and we get to bring it to the global audience for you so you can have success in your shops. Andrew, I'm never gonna steal anyone's thunder, but we're talking 30 taper, cutting steel, high speed, rigidity, the base is heavier. There's so much to this machine. I feel like I should have known about it before today, but I'm really happy to be here to share it with the audience. Would you mind talking about some of the details of this machine?
Yeah, no problem. First of all, thank you for the opportunity to use this platform to talk about our equipment. First and foremost, what we've done here is we've done a few different demos across the machine. We all know that 30 taper does very well in a speed environment with aluminum, with some non-ferrous materials. One of the major drawbacks on the equipment is, what does it do with steel? So what we wanted to do is we wanted to actually show and demonstrate a nice, very rigid part that can be done here. So we are milling this from a nice blank, as you can see over here. We're roughing that from here.
That's a beast of a part. You guys know how strong I am. You see that big muscle? Don't worry about it. This is not aluminum. We're cutting steel on a 30 taper, and significantly as well, aren't we?
Yes, we are. We had the demo queued up, but you know, it's a little loud, so we don't want to get into too much. We won't be able to hear ourselves because it's actually really ripping the material. But some of the reasons why we can do that is our casting compared to competitors in the marketplace are roughly 25 to 30% heavier, our casting. We've got a different design inside the spindle that allows us to grip our tool harder against the 30 taper, big plus for the dual constrained phase. Also, we are using roller guides versus ball guides. So all those three components allow us to cut the material without having to back down like some of our competitors do in the marketplace.
Well, we have three different machines here, so we're gonna walk from one to the other, and I wanna discuss some of those points as we do so, right? Because I think it's important. The first thing that comes to my mind, and probably yours as well, because you guys are smarter than I am out there, and there's a large crowd behind us that all know they're smarter than me as well, which is good, is the 25% or more of the casting itself. Immediately we think of rigidity, right? We think if I have more on that base, the vibration dampening that goes into it, the amount of load, the depth of cut I can put on the machine is going to be increased. But you also mentioned something about the way you're holding the tool. Could you talk more about that?
Yeah, so inside of our spindle design, our competitors use a 3-ball detention design. So they're gripping in 3 points around the retention knob to pull back. We're actually using a full collet design, which goes all the way around, which allows us to put more force on the pull stud and pull it tighter against the taper and the face contact.
That seems simple enough, but I also know how effective it is. Let's head on over to this other machine here, Andrew.
I'll follow you.
Absolutely. So the first machine, we were cutting a piece of steel. Now it looks like we have some sort of, for lack of a better term, some sort of pallet pull in here that's going to rotate in and out for a style of automation. Is that what we're looking at here?
So this machine is what I would call a simple form of automation. It's inside the machine, designed into the machine. What it allows us to do is open the door, and we can load and unload parts while it's machining behind. So what we're able to do is maximize our spindle utilization by minimizing our downtime. The nice thing about it is once we're done, we close the door, hit pallet ready, and it's an automatic mode. 4.5 seconds, we're back into the cut. Now, some of the design features on this machine compared to competitors in the marketplace is we actually, I'm going to open this back up, but we actually use a curvic coupling design on our table. Our competitors tend to use a servo motor against a stop pin. We are actually a lift table, rotate 180 degrees, sit back down in a round curvic coupling for rigidity and support when we're machining and putting side load on the parts.
Andrew, this is normal for you, but I want to make sure that the audience is also educated. What are some of the benefits of that style of loading and unloading when it comes to this change of parts?
So when we're changing this over in this style of unload, what it's going to do, number one, the table is very, very rigid. So when we put a side load and cut against the grain of the table, push against
Right.
push against the table. The curved coupling itself allows us to lock into place, so we're not going to get any drift with the table, number one. The other thing, if we want to go back to throughput, what it allows us to do is it's going to increase our spindle utilization from a standard BMC over here to a pallet change. It's going to take our spindle utilization from about 65% to about 85%. And then that would lead us into automation, which would get us to about 90 or 95%. So
okay, that is impressive. I do appreciate you clarifying. I always like to be sure, we sometimes realize, or maybe we don't realize, our own brilliance, right? Which you have a lot of, and we'll talk to people as if we all know the same stuff, and I love to break it down so that people like myself can truly understand what's going on. And that makes perfect sense to me, which allows me to apply those heavier cuts because I'm having the resistance in the opposite direction, allowing me to take those deeper cuts. Should we move over to the full automation cell?
Absolutely, after you.
All right, so as we're doing this as well, I just kind of want to talk about automation in general being important. We now know, starting from the first machine we were at down there, we said, okay, we have a heavier base, 25%, if not more. We said we're holding the tool a little bit differently, which allows us to cut heavier. I tried to pick up a steel piece and almost fell down, so it's very obvious you're cutting steel as well. But we're talking 30 taper. We're talking 15,000 RPM, I believe, as well. And we're talking very accurate micron-style machining parts. Have I missed anything before we start talking about automation?
Actually, I want to back up just a second, if you don't mind.
No, I'd love to.
I want to talk high level for a moment. So high level, if we're taking a look at the way we manufacture, we look at, for an analogy, let's look at a lathe department inside of a shop. We've got a 6-inch chuck, we've got an 8-inch chuck, we've got a 10-inch chuck. Then what do? We diversify, we add a sub-spindle, we add a part sketcher, we get live milling, maybe a B-axis someday. If I look at my mill department the same way I would look at my lathe department, I would want to say that there are parts that go on 50 taper, there's parts that go on 40 taper, there's parts that are meant for 30 taper.
Sure.
The goal inside your shop is to find the right size part with the right capabilities, put it on the right machine with the right capabilities, and maximize your profits. So how can we do that for you? Number one, go back to the first machine. Let's go back to the first machine. Number one thing that we're going to do is we're going to put more parts in the box at the end of the day by speeding up your cycle time. Number two, we're going to increase your spindle utilization by giving you simple automation. And number three, we're going to give you unattended here at this automated cell. We're going to give you unattended automation or production during breaks, during off shifts, during lunches, and just have a continual, consistent run. So all in all, what you're looking at is we diversify parts of our shop, but sometimes we feel on the machining side of things, we just need a 40 taper. We just need a 50 taper. We're doing this. I don't know what's coming into my shop today. But if you diversify your shop, what it does, it gives you the capability to open up capacity untraditionally by taking parts that maybe aren't maximize their profits and putting it on the right platforms. So on top of the automation and the capabilities that we've demonstrated here today, those are some things to think about when you're looking and quoting things for your shop, because you look at it and you say, I may not have the profit in here I want, so it's not a good job for me. Maybe you just don't have the right platform.
I agree with you. And then in addition to what you're saying, because we do need to diversify, and there are parts that deserve different types of machines in order to optimize that process instead of just throwing it on there, right?
Exactly.
And something else that sticks out to me is real estate space. This is not overly big. So if I can take a 40 or 50 taper machine and cut the same materials on the 30 taper machine with a smaller footprint, why wouldn't I do that? Especially if it's going to be faster because of the feed rates and everything as well.
Well, let me add to your point. So another thing that comes along with these is not only the real estate, but what about the green initiative? We're going to be using less power, less waste, less materials. It all goes hand in hand, and we know what the real estate cost comes. We also know what's going on in the world today with the electric costs. So why not maximize the profits from all sides? Not only more parts in the box at the end of the day, but let's use less energy in that and floor space to make more parts.
Less energy, more money in our pockets. Why not do that for sure?
We all know that shop owners are in business to make money. At least that's what I've heard.
Gosh, let's hope so. Let's hope so. All right, so I have to ask the hard question, Andrew.
Sure.
We've gone from 1 machine, 2 machine, 3 machine. We've talked automation. We've talked rigidity. We've talked precision. It's very easy for me to see that this is a high quality machine.
Right.
Why, knowing that I've done lots of interviews, why hasn't this voice been amplified? Why haven't we heard of this more, other than the fact you brought this in to Gosiger January 1st of 2023, right, and we're really introducing this to the Western world? Why else? Where have you seen this before, and what are we bringing to the American audience?
So let's talk about the line for a moment here. So what we have is we have a few models, and we're only able to demonstrate a few things today, which we are demonstrating the DST 40A, which is a single table, single spindle, 3-axis mill. Then we have the DST 36D, which is a pallet changing version. What a lot of people don't know, and we've actually just recently sold out of, is we actually have a double spindle machine as well.
You have a twin spindle as well?
We have a twin spindle as well.
Of course you do. Why not?
Exactly. So what that allows us to do is when we're taking the spindle utilization and getting that up to 85% over there, yeah, we still might be running at 65% because of the no automation and the no pallet change, but I'm actually getting 2 parts every time we do 1 cycle. So your throughput is actually 150% to 160% of what you can do over here. So
I like that math.
So that's exactly why we're out of stock of them right now. So
well played, my friend.
But to go into your question and answer your question a little bit more, why are we just now hearing about it? So Gosiger has been a longtime partner with Nomura on the Nomura Swiss side, and Nomura Swiss has partnered with a couple companies out there to make different pieces, parts, and components. At some point in time, those 2 companies merged. At that point in time, they started dabbling in the drill tap market, and somewhere around 2015, Gosiger got very interested in this product line. So we brought a few over, we put them through the tests, we went through reiterations of the machine, told them, no, we need this, we need that fixed, we need this fixed. And
let me just interrupt you real quick. He says since 2015. You've been testing this since 2015.
Yes, we have.
Okay, please continue. I just had to make sure I heard that correctly.
So what we with all the testing and everything, we finally got these versions of the machine in 21, and decided in late 22 that we were going to make a go of it. So we put a bunch of machines in inventory, filled our parts department full of recommended parts that were needed as we go, and decided to launch on January 1, 2023, and that's where I came from.
That is an incredible story. For everyone who's watching, if you've heard of this, fantastic. You know the quality that's involved, this Korean-made machine. You know Andrew and his longevity in our industry as well. However, if this is new to you, I hope this has been beneficial. We've tried to go through every aspect, from twin spindle to cutting steel to the strength and rigidity of the base and the added weight, the precision and accuracy, the automation, from simple automation to still simple, but I guess more complex automation. And if you have any questions, my friend Andrew here is the man. He's got the history to make sure to answer all your questions. And of course, Gosiger, who's been around for over 100 years, who's been testing this machine since 2015, is here to answer all your questions as well. Andrew, did I leave anything out? Did we cover everything? How are we doing?
I think we got everything. I think we did good.
Oh, you are amazing, my friend. I definitely appreciate you. Thank you all for watching. We appreciate your time, and we'll see you again soon.